This is the fourth question. Here, they given the number of particles crossing a unit area perpendicular to the x-axis per unit time is given by n equal to minus d n2 minus n1 divided by x2 by x1, where n1 and n2 are the number of particles per unit volume for x equal to x1 and x2 respectively. Find the dimension of d called diffusion constant. Alternatives are m0 lt power square lt power 2 or m0 l square t power minus 4. And the third one is m0 l square t power minus 1, and the last one is m0 l square t minus 1. So here the formula is given this one. So the formula is given as the formula is here n is equal to d into this one. So from this we have to calculate d, isn't it? So first we will write d. D is equal to, so n into x2 minus x1 cross multiply divided by n2 minus n1. This is the formula. Now substituting the dimensions of n, x2 minus x1, n2 minus n1, we get the answer. So what is the dimension of n? So here the number of particles n crossing a unit area perpendicular to the x-axis per unit time. So n is the number of particles. So number of particles does not have any unit. So dimension of n is number of particles does not have unit. Number of particles crossing per unit area. Per unit area means, so divided by area, it is a L square, and then per unit time. So the time should also be in the denominator. So it is 1 by L2 into T. So dimension is L power minus 2 T power minus 1. So dimension of n is L power minus 2 T power minus 1. What is x2? x2 and x1 are given as a number of particles per unit volume, and x1 and x2 are given as a distances. So x2 as well as x1 is a simple dimension of a length. Then what is the dimension of a n2 and n1? n2 and n1, they are given as number of particles per unit volume. Number of particles per unit volume. So n2 or n1, if you take anything, then it is number of particles, it does not have any unit, per unit volume. Volume is L power 3. So L power minus 3 is the dimension. So three things. One is n, the dimension is L square minus 2 t power minus 1. Other one is L, the third one is L power minus 3. Substituting in this formula, we'll get the answer now. So we'll go for substitution. So it is n, instead of n and x2 minus x1, I have to substitute, isn't it? So instead of n, I can substitute L power minus 2 t power minus 1, and then the next unit is x2 minus x1, the dimension is L, and n2 minus n1, the dimension is so I have to rub this off. So let us rub this off, and then I will substitute. It is L power minus 3. So this is the dimension. So substituting this, so we'll rub this, the remaining things, so it will be easy to get the answers now. So we have substituted the dimensions of all the quantities here. So the answer is L power minus 2L. So it is going to be L power minus 1 T power minus 1. So because this one, this, and this one, this will get cancelled. So L power minus 3, if it goes to the divided by L power minus 3. L power minus 3, if it goes to the numerator, it will become L power plus 3. L power plus 3 and L power minus 1, it is L square, isn't it? And then T power minus 1. So it is L square T power minus 1. Instead, if you want to include m, we can include the m as like this, m power 0, L square T power minus 1. So the answer is C. n0 L square t power minus 1. That is the answer for the fourth question. So we want move on from the fourth question to the